All right, hello everybody. So today we're going to continue our discussion in Chapter 5, Section 2, and we are going to discuss what a natural logarithmic function is. And essentially, the natural logarithmic function is exactly like the log base 10 or any other base. The only difference is natural log is simply log base e. So you can see right here, this gives us a definition of what log, or natural log I should say, is, which natural log is simply log base e of x. Now, thing to keep in mind, if you have log of x is base 10. They don't need to write the 10 if it's not written. If there is no base written there, it is understood to be base 10. But there could be any base there. There could be a 10, there could be a 2, there could be a 7, or in this case, if we put an e right there, which is the irrational number e, that is denoted using the natural log notation. And you do have a button on your calculator for natural log. You can see that the log button is on the left part way down. The natural log button is right below that, and it's the ln key. So pretty much all the same rules apply to natural log as we learn for logarithmic functions, because natural log is just a specific base of the log function. And so you can see here is the graph of e to the x. Okay, that's an exponential. F of x equals e to the x. And the inverse of that is the natural log of x. Remember, logarithmic equations are the inverse function of exponential equations. So there are the two graphs. You can see that they are reflected about the line y equals x, which is that dashed line you see right in the middle. And so they're just flipped about that line. So the first part says use a calculator to evaluate the function f of x equals natural log of x at each value of x. So this is pretty simple and straightforward, just like we did before when we were evaluating logarithmic functions. To evaluate a natural log, you're simply going to use the natural log key. So in this first one, part A, they want us to take the natural log of x. So we will hit natural log, and then in for x, we are substituting 2. And then we close out our parentheses and hit enter, and you can see it is 0.693. Now the next one, we have natural log of 0.3. Once again, close out your parentheses and then hit enter. And we have the next one, part C, natural log of -1. Now, maybe that might ring some bells about something we might have talked about prior to this video about taking log of a negative number. But as the same with logs, natural logs cannot be taken of negative numbers. And it has to do with the domain of the log and or the natural log function. Natural log and log can only be done on positive numbers. You cannot do them on 0, or you cannot do them on negative numbers. So as an example, if I try to take natural log of 0, you're going to see that we also get a domain error for that one as well. So only numbers larger than 0 can be logged. Now the last one we're going to try here is natural log of 1 plus the square root of 2. So we'll start by hitting natural log 1 plus, and we have the square root of 2. We close out our parentheses and we hit enter, and you can see we get 0.88. So there you go. It's pretty simple, the natural log key. Remember, on your regular scientific calculators on your phones, if you do need to use those for whatever reason, if you tilt your phone to the side, so rather than being up like this, tilt your phone sideways, and you will get the log and the natural log keys to show up. So as we had with the log functions, we are also going to have properties of natural logs. And all of those properties are the same that we've already done. It's just they're showing ln versus log. And they are all the same. If you take the natural log of 1, that will always equal 0. If you take the natural log of e, that will always equal 1. The reason being here, remember, natural log is the same as log base e. So if you have natural log of e, that's the same as having log base e of e. Remember, these will all kind of cancel out, and they just turn into 1. So anytime the base of the log matches the number that is being logged, you get a solution of 1. So for instance, log base 2 of 2 is equal to 1. Log base 10 of 10 is equal to 1. All of those are true. Now the next one shows that if you have natural log of e to the x, then that just equals x. And so this here again is the natural log's base. This is base e. So anytime these two match, they're going to cancel, and this all cancels, and it's just left with x. So that's another one of your rules. That is called the inverse property. The last one is called the one-to-one property. And that one says that if natural log of x equals the natural log of y, then we can say that x equals y. All right. So those rules, as I said, should be familiar to you because we've already learned them in a previous section where they applied to regular log functions. So we want to graph the following. Okay. Now remember, logarithmic functions all pretty much look the same. Natural log is going to look the same as a logarithmic function. Natural log is just log base e rather than some other base. So keeping in mind what a graph looks like of a natural log function. If I were to graph the inverse of that, so we take this right here. Now we have this coordinate plane, and we want to draw a graph of the natural log of 3 minus x. So let's figure out what's going to happen here. So the normal graph of an exponential would look like this, and the graph of a logarithmic function would look like this, because it's a reflection about the line y equals x. So let's get rid of the exponential for a second and just take a look at the exponential function. So here's what a logarithmic function looks like. Now, what is happening in this? There's two things happening, transformations, right? First thing I would suggest doing is we should reorder this. So it's f of x equals the natural log of negative x plus 3. Now, the reason why I reordered that is because I think it's a little bit easier to understand the transformations that are going on. The first transformation we will look at is this negative directly on the x. When there's a negative directly on the x, it will cause a reflection about the y-axis. So we reflect about y-axis. Okay. The next one is this plus 3. Now, when there is a negative directly on the x, it reverses this plus and makes it go the way you think it should go. It is inside. It affects it horizontally. So that will be a shift right 3. Okay, so we are going to reflect, and then we will shift it to the right 3. So looking at this graph that we have, if I did these in stages, the first graph that I would have from my basic logarithmic function is I would reflect it, and it would look like this. Okay, and then lastly, we would take that graph and we would shift it to the right 3. So it would come to the right, 1, 2, 3. So now you can see it up there, but I'm going to sketch it also. Your graph will look something like this. So we reflected, and then we shifted to the right 3. Okay, that's what I have for you today. As always, if you have any questions, feel free to email me. Have a great day.